Hello. The following is example 4 from chapter 2, section 7. I'm going to talk about the reflections of parent functions, or the reflections of any function, honestly. Reflections occur when you are multiplying by a negative effectively. So you would see a reflection if you see something like this. Y equals negative f of x, or y equals f of negative x. Now notice that if it's outside, it affects the y value, and if it's on the inside, it affects the x value. Now, you'll see why here in a second, but if it's on the outside, that's a reflection across the x-axis, because the x value does not change. It's a reflection across the x-axis. And here, it's a reflection across the y-axis, because it's the y value that does not change, because this is inside the parentheses, which means the x value is the one that changes. I hope that kind of makes sense a little bit. You'll see why here in a second. Now, to illustrate this, I'm going to use a function that I didn't really do on the parent functions, but it can be good for you to know. It's y equals the absolute value of x. Now, absolute value, of course, simply means the distance from 0. And the domain is all real numbers, and the range is 0 to infinity, including 0. So my parent function is actually going to be very similar to y equals x squared, because I need numbers to the left and to the right of 0. So I'm going to use negative 3, negative 2, negative 1, 0, 1, 2, and 3. Now, the y values, of course, just plug in the x values. That gives me positive 3, positive 2, positive 1, positive 0, positive 1, positive 2, positive 3. Now, if I wanted to graph this, here's what it would look like. It's not going to look fantastic because, well, honestly, it's kind of tough to graph on here, and I can't get a straight edge to use. So it's going to be going this direction over here, and this direction over here. Hey, that doesn't look too bad. Okay, so what I want to do is I want to make this look like y equals negative absolute value of x. Now you actually already know how to do this. Because the negative is on the outside, it is a reflection across the x-axis, which means the y value is what changes. But you already know that because if you think of this as negative 1 times the absolute value of x, what happens here is that you just use what we just learned. So because it's on the outside, it affects the y value, and you do what it says. So this says multiplication, so I'm going to multiply, and it's on the outside, the y, by what it says is negative 1. So a new xy table. Because we're affecting the y value, the x's all stay the same. So negative 3, negative 2, negative 1, 0, 1, 2, and 3. Except the y values, I multiply by negative 1. So it gives me negative 3, negative 2, negative 1, 0, negative 1, negative 2, and negative 3. If I was to plot this, here's what it would look like. Notice the V shape is maintained. There we go. Notice though that what happened here is we reflected about this axis. Whatever was on top went to the bottom. And whatever was on, if there was anything on bottom, it would have gone to the top. And so on and so forth. Now, look at what we would, well, actually, instead, I want to go ahead and erase this over here. And instead of absolute value of x, I'm going to show the y-axis by doing the square root. 1 second. Okay, what we want to do is, again, we want to start out with y equals, in this case we're going to do the square root of x. And the square root of x, you already know the parent function, xy, is 0, 0, 1, 1, 4, 2, and 3, 9. And what I want to do is I want to make this into y equals the square root of negative x. And because the negative is on the inside, that makes it a reflection across the y-axis this time. Now, again, you already know how to do this because there's a negative there on the inside, and it affects the x value. Okay, so notice you can think of that as negative 1 times x. So what I need to do is I need to do the opposite of what it says. So it says multiply by negative 1, so I do the opposite, which is divide. So I'm going to divide, and it's on the inside, so it affects the x, and we're going to divide it by negative 1 because of that. And since it's the x that changes, the y stays the same. And that's the reason it's a reflection across the y-axis. So the y stays the same here, so it gives me 0, 1, 2. Someone should have stopped me. Why didn't you not stop me? That should be a 3 right there. Let me change that real quick. Whoa, I went crazy, didn't I? That should be a 9. Okay, so 9 and 3, just to emphasize that I had it wrong. There we go. 1, 2, and 3 there. Okay, that's better. So 0 divided by negative 1 is still just 0. 1 divided by negative 1 is, well, it's negative 1. 4 divided by negative 1 is negative 4. And 9 divided by negative 1 is negative 9. Okay, so I'm going to graph both graphs here. So the first thing I'm going to graph is y equals the square root of x. So it was 0, 0, 1, 1, 4, 2, and 9, 3. There it is. And now I'm going to graph the other one. It was 0, 0, negative 1, 1, negative 4, 2, and negative 9, 3. Notice that this time it's actually going the other way, and anything from the right went to the left, or if there was anything on the left, it would have went to the right, and so on and so forth. Notice that you can see this by, if I have this inside the radical, I can say negative x must be greater than or equal to 0. Divide by negative 1 means x must be less than or equal to 0, and that's your domain. And you can see that happening here.